So welcome back. So today in this experiment, we're going to see about the implementation of hierarchical clustering using agglomerative clustering on a data set. So as usual, we import certain libraries that is required: pandas for data pre-processing, numpy for numerical Python, and for matplotlib for visualization, and certain sklearn imports for pre-processing for the clusters and everything. So next, what we're doing is we standardize the data. That means the mean becomes 100 and the standard deviation becomes 1, because it is this step is important because we do clustering algorithms depending on the distance and unscaled data giving misleading results. So next, what we're doing is that we are applying linkage and we are plotting the dendrogram. So we apply the linkage function using a single linkage with a distance matrix of Euclidean distance, which helps us to create the dendrogram where how clusters are formed. So right here, so we understand how the clusters are formed, and we initialize how many optimal clusters are formed here as well. And then we go on to make clustering models. First one, with model 1 we're doing it with number of clusters with number 3, and for model 2 we're doing with the 4 number of clusters. And next, what we do, we fit the models, we predict cluster labels for each data points, and these cluster tables for each, for 3 clusters and for 4 clusters, the labels indicate where each data point belongs. And next, we visualize the clusters with the x-axis as alcohol and y-axis as malic acid. It represents a different color to understand that the data is grouped there. And then we go for evaluation, like performance metrics, some sort of. So we're doing first a mutual information score, which measures similarity between the clusters and actual data, and then the silhouette score for each of the clusters. So we have taken model 1 for 3 clusters, and for that, the model 1 we're taking the mutual information silhouette score and the Davis Boolean index, where each of them defines as I said already about mutual information score, it measures similarity between clusters and actual data. Silhouette score measures how well the clusters are separated, and it is a best preference that higher values are great, and it is good for clustering. And next, the Davis Boolean index, which is measures cluster similarity, and for that lower value is better. It's completely opposite to silhouette score. So these metrics compare the quality of clustering. So as you can see here, for model 2 4 clusters, mutual information score, silhouette score, and Davis Boolean index is also calculated there. And next, for best model selection, we took model 1, because when we see the previous question, the silhouette score is higher for model 1 than for model 2. So where there is a higher silhouette score, it is considered as the best model. So we just took model 1 with 3 clusters as the best model for the uh, for the data set. So